digit before the 9 is a 2, and 1 more than that is 3. So 3 is the ekadika, the 1 more than. And we divide 1 by 3. We know it starts with the 0 point. 1 divided by 3 is 0, remainder 1. 10 divided by 3 is 3, remainder 1. 13 divided by 3 is 4, remainder 1. What do we have next? 14 divided by 3 is 4, remainder 2. 8, 2, remainder 2. Let me know if I make a mistake. 22 divided by 3 is 7, remainder 1. 17 divided by 2, by 3 is 5, goes 5 times. 5, remainder 2. And then we've got 8, remainder 1. And we've got 6. And then 2. How long is this going to go on for? Then we've got 0, remainder 2. 6, remainder 2. 8, remainder 2. 28 divided by 3 is 9, remainder 1. 19 divided by 3 is 6, remainder 1. Oh, look. 16 divided by 3. 19 divided by 3 is 6, remainder 1. Then we've got 16 divided by 3 is 5, remainder 1. And you can see now the complement digits coming up. And so we can just rattle off the remaining digits like this: 2, 4, 1, 3, 7, 9, 3, 1, recurring. And there is a way in which we can determine when we are halfway through, because the halfway through point here, at 28, that is the difference between the denominator 29 and the numerator. 29 minus 1 is 28. Back up here, you can see that this 16 here is the numerator, the denominator minus the numerator. 19 minus 3 is 16. And so that gives us another way of determining the halfway stage, where we can then start using the complements. And if we want to, I won't go into this. Oh, well, this 1 over 29 here, that's got 28 digits, and very easily very easily found. We can extend the method to denominators like 13, because 13, by multiplying top and bottom by 3, is 3 over 39. And now we've got a situation in which the denominator ends in 9, or 1/7. Multiplying top and bottom by 7, we get 7 over 49. And we can use the same method to arrive at the answer. The author of Vedic mathematics, Shankaracharya Sri Bharati Krishna Tirtha, he gives the 1 over 19 example as a spectacular introductory example. But now I'm going to show you something different, which you may find of more practical use, which is in multiplication. I should point out at this point that in Vedic mathematics, there are special case methods and general methods. So there are many special case methods which make mathematical work very easy under certain circumstances. And then there are general methods to cover everything. Well, an example of a special method might be this: if I want to multiply 19 by 5, I can say, well, 19 is very close to 20, so 5 times 20, and then use the deficiency to adjust the answer. I'm just going to introduce you here to the general method for multiplication in Vedic mathematics, and this applies to numbers and polynomials as well. So just analyze what happens when you multiply two numbers. Let's say we have 23 multiplied by 12. It's going to have 3 digits in the answer. It's going to have a hundreds digit, a tens digit, and a ones digit. And if you analyze this, the only way in which we can get a hundreds digit is by multiplying 20 by 10, which is 200, of course. It's just 2 times 1, which is 2. The only way in which we're going to get a ones digit is by multiplying the 2 ones digits here. 2 times 3, 6. The tens digit, however, is going to be brought about by multiplying the ones here by the tens here. So that's 2 times 2 is 4. And this ones digit 3 by this tens digit 1. 3 times 1, 1. And then adding these two together. 3 add 4 makes 7. So the process here is to multiply 2 by 1 vertically, giving 2. Crosswise, sum of the cross product is 7, so that's crosswise. And then vertically, 3 into 2 goes 6. And hence the sutra for this is urdhva tiryambhyam, or vertically and crosswise. And you can work it from the left or from the right. So if we have 37 multiplied by 42, if we work from the left here, we will have 3 times 4, 12. Then we're going to have 28 add 6, 34, which is 4 with 3 to carry. And then 7 into 2 is 14, so that's 4 with 1 to carry. However, we then need to look after the carry digits. There's 1, and there's 3 goes here. And if we work from the right, that's fine too, because remember, Vedic maths is flexible. And working from the right, we'll be able to bring in the carry digits as we go. Now, this vertically and crosswise method is extendable. We can extend it to multiplying, excuse me, 3 digits by 3 digits in one line. So let's have a look at that. Example 213 multiplied by 246. This time we're going to work from the right hand end. Now I can represent the pattern of vertical and crosswise here with these dots. So each dot is represents a digit. And the first step is to multiply vertically the 3 and the 6, giving 18. Then, same as before, crosswise, I'll write the dots out again. Sum of the cross product here would be 12 add 6, 18, add in the carry 1 is 19. The third step is the largest one. is this cross product. Hundreds by ones, tens by tens, and ones by 100s. So we get 12, add 4 is 16, add 6 is 22, add the carry 1, 23. And the fourth step is rather like the second step, but over here. To get 8, add 2 is 10, add 2 is 12. And the final step is just to vertically multiply the two hundreds digits and add in the carry 1 to give 5. And we can work this from the right to the left or from the left to the right. So that's a simple extension of the way in which multiplication is worked. And the sutra here is vertically and crosswise. Okay, so that's all very well and good. And if you're still at school, that for school children, that's a very useful way to multiply numbers. But being at college, you don't do much multiplying of numbers. What you do is multiplying polynomials. So let's have a look at that. Now I'd like to go with, I'll come back to this 23 times 12. The algebraic equivalent of that is 2x add 3 multiplied by 1x add 2. And applying exactly the same pattern of workings, 2x times x is 2x squared. And we have 2 times 2x is 4x, 3 times x is 3x, add 4x, add 3x is 7x. And then 3 by 2 is, 3 times 2 is 6. Now, if you compare these two, you can see that the coefficients in the quadratic here are exactly the same as the digits in the answer 276. And you can understand that through the substitution of x is 10, because if we let x be 10 here, this number will be 20, 2 tens add 3, which is 23. There it is. And this would be 12. And in the answer, this is x squared is 100. So put 2 hundreds, add 70, add 6. And one of the features of Vedic maths is that there is an interlinking between the algebra and the arithmetic. Mostly through this substitution of x is 10. Okay, so now we can extend this to multiplying two quadratics, like 2x squared plus x plus 3 multiplied by 2x squared plus 4x plus 6. And we can do this in one line of working using the vertically and crosswise pattern, which was shown here. So working from the left, because that's the way we generally work from the left, because that's the way we write and we read in that direction. Unless you speak Arabic, I suppose. Anyway, 2x squared times 2x squared is 4x to the 4. And then we crosswise this way and this way. We have 8x cubed plus 2x cubed is 10x cubed. Then crosswise here, 12x squared, add 4x squared is 16x squared, add 6x squared is 22x squared. Crosswise here, 6x add 12x is 18x. And then 3 times 6 is 18. 6x add, that's an 18x there. Now, the coefficients here, 4, 10, 22, 18, 18, they don't quite look the same as the numbers here. But if we were to do this multiplication without adding in the carry digits, you would have 18, and then 6 add 12, 18, 22, 10, and 4. It's only when we add in the carry digits that we get the 5, the 2, the 3, the 9, and the 8. So you can see that the arithmetic methods are really the same as the algebraic methods. And in fact, many of the arithmetic methods in the numerical methods in Vedic maths come directly from an algebraic algorithm or system. And the same is true with division and working with polynomials and powers and series and so on. We've got time for one more example. And I'll show you another instance of how the algebra and the arithmetic work. There's a method in Vedic maths for cubing 2-digit numbers, which I'd like to show. So I'm going to take, as an example, 12 cubed. And this method is delightful. First of all, I really like it. This works like this. The method is to write down the cube of the first digit. The cube of 1 is 1. And then to set out a geometric sequence consisting of 4 terms using the ratio of the 2 digits. Now the ratio of the 2 digits here is 1 to 2. So we're just doubling, and double of 1 is 2. And then double of 2 is 4. And then double of 4 is 8. And so we have this geometric sequence consisting of 4 terms, where the first term is the cube of the first digit, and the last term is the cube of the last digit. 8 is 2 cubed. So that's the first step. The second step is to double the middle 2 numbers. Double of this 2 is 4, and double of this 4 is 8. And the last step is to add up each column. So here we have 8. Here we have 12. Here we'll have, that's 2 with 1 to carry. So that's 7. And that's 1. 1728. 13 cubed. Okay, I'm going to give you a minute to work this one out. We set down the cube of the first digit and then use the ratio 1 to 3. So I'll give you 60 seconds to see if you can find the cube of 13. Okay, so the geometric sequence then will be 13927, and note that 27 is the cube of the last digit 3. And then we double the middle two numbers, 6 and 18, and then add up. This is 7 with 2 to carry. This makes 29, with 9 with 2 to carry. Then we have 11 and 2. And if we, I'll take a more sophisticated example, 32 cubed. The cube of 3 is 27. The ratio here is 3 to 2. So we're going to divide by 3 and multiply by 2 to get 18, 12, 8. Double the middle two, 36 and 24. And then add up. We've got 8 with 36, which is 6 with 3 to carry. We get 54, 57, 7 with 5 to carry, and then 32. So that's the answer. And that's a delightful method. Well, but so you can cube two-digit numbers using this, but how does it work? Let's have a look. Let's suppose we have the first digit is A and the second digit is B. We're going to cube this. And the method was to set down the cube of the first digit, so that's A cubed, and then to multiply this by the ratio. Well, what is the ratio A to B? The multiplier will be B divided by A, just as the multiplier here was 2 divided by 3, 2/3. Here it's B divided by A. If we multiply A cubed by B over A, that would be the next term. And then A cubed times B over A times B over A again will be B over A squared. And then A cubed times B over A cubed. And if we simplify these 4 terms, we get A cubed, A squared B, A B squared, and B cubed. And then we doubled the middle two. So that would be 2A squared B and 2AB squared here and here. And then we added up everything. And this will give A cubed plus 3A squared B plus 3AB squared plus 1B cubed. And you will recognize that as the binomial expansion of A plus B cubed. So in fact, this method is based on binomial expansions. And again, this is an example of how the algebra interlinks with the arithmetic in Vedic maths. So that's just a few examples of Vedic maths, and I hope you enjoyed that, and I look forward to working with you in the future as well. So given a few illustrations to really show some of the unique characteristics of this approach to mathematics. So thank you.
Thank you so much, sir.
If there are any questions, I'd be very happy to answer.
Sure, sir. We have an interaction session after this now.
Okay.
So first of all, from the organizing team, we would like to thank you for opening our perspective to the Vedic system and mathematics in this, which is involved here, thereby enhancing our understanding about the subject in such a simplified and detailed manner. We are glad that our students got a chance to learn from your expertise. So now we proceed further to the interaction session. At the onset, medal holders of Vedic Olympiad who were students of master's program at that point and now faculty in the department. I invite Ms. Nidhi, Ms. Bharti and Ms. Mansi to share their experiences one by one.
Thank you so much, ma'am. Every mountain top is in reach if you just keep climbing. So, very good afternoon to one and all present here. Myself, Nidhi, and it was matter of great pride that I got the gold medal along with the third rank in the world in the Olympiad, which was held by the very first time by the Institute for the Advancement of Vedic Mathematics, UK. Thanks to the Institute, IAVM, UK. Respected sir, thank you so much. And special thanks to ma'am Veena ma'am and Mrs. Anand ma'am for their supporting us. They always support us and encourage us to do such exams so that we can encourage our qualities. So special thanks to both of you, ma'am. And at last, I want to say a few lines for my students also. जीत के खातिर जुनून चाहिए, जीत के खातिर जुनून चाहिए, जिसमें उबाल हो ऐसा खून चाहिए. ये आसमान भी आएगा जमीन पर, ये आसमान भी आएगा जमीन पर, बस इरादों में जीत की गूंज चाहिए, बस इरादों में जीत की गूंज चाहिए. थैंक यू सो मच.
Very good afternoon to all, one and all present here. First of all, thank you to thanks to my teacher who gave me the opportunity to introduce myself. My name is Mansi, and first of all, I still remember that day when I passed my Olympiad IAVM, which is conducted by IAVM. And basically, I realized that IAVM provides a platform to the student where we realize that we have to test the individual knowledge and their skills in Vedic mathematics. So I think they provide a platform to test the individual knowledge of the students. So thank you, IAVM, for providing this great opportunity to the students. Thank you.
Coming together is beginning, working together is progress, and staying together is success. Good afternoon to one and all present here. Good afternoon, ma'am, and good afternoon, Anand, ma'am. I was one of the participants of the Olympiad, which was held on 11th September, and I got the bronze medal, and it's a matter of great pride for me. First of all, I would like to thank to Anand ma'am, Veena ma'am, and special thanks to IVM team who gave us the opportunity to participate in this competition. Thank you very much to one and all present here.
So I welcome the volunteers from the students for being. We are also open for your doubts from the sir regarding the talk which we had. So if you want to ask anything. So, sir, are we audible?
I can yes, I can hear.
Okay. So first of all, a very good afternoon, sir. I am the student of Bachelor's Honors Mathematics in semester 3, and I would like to thank the Faculty of Mathematics that they have given us such a great opportunity to be more interactive with wonders of Vedic mathematics. So my question basically is that according to your research, I have heard that you have been being in a research for over 26 years, which means you must have came across with students with different backgrounds. So my question basically is that how could Vedic mathematics can be helpful from someone who is coming from different backgrounds? Like we are a mathematics students, but I would like to ask the question like someone who is coming from IT background or any other background which is somehow connected with mathematics, how could Vedic mathematics can be helpful for them? Thank you, sir.
Okay, well, there are two aspects to this. The first has to do with the universality of mathematics, and the second has to do with the wide applicability of the Vedic sutras. So let's deal with the first. You may have noticed that when you're at school, you learn numbers. And the 9 numbers and the 0, together with place value, originate in India. Okay. Now, if you consider what happens in schools all over the world, every child in every school all over the world learns these 9 numbers and the 0 and how to and their relationships. So in that sense, mathematics is universal. There are no children in schools in any country that do not learn these numbers. So that's the first aspect, it's universal. The second is that the Vedic sutras do apply to mathematics in any field. So, for example, in analytic geometry, like even simple analytic geometry, like equations of straight lines and so on, the sutras are still present. It is a mistake to think that Vedic mathematics always provides you with an alternative method for working out a problem. This is not so. It does have alternative methods, yes, but the sutras apply to any type of mathematics. So when I'm doing just a conventional piece of mathematics, I ask myself the question, okay, what sutra is operating here? Let's take a very simple example. When you divide by a fraction, children all over the world learn to swap over the digits of the second fraction and change the sign to a multiplication sign. The sutra for this is Paravarcha Yojayet, transpose and adjust. While that piece of mathematics is very conventional, and yet the sutra there just describes that operation. In other fields, more advanced areas of mathematics, the sutras also apply. But they are, how should I put it? They are to do with how your mind works in the present moment. So Vedic gives a more personal approach to mathematics, because it looks at how your mind is working with whatever aspect of mathematics or engineering or technology you are working in. And the sutras don't just apply to mathematics either. They have a wider field of application. I'm not sure that answers your question, but I've tried to.
Thank you so much, sir.
Good afternoon, sir. Sir, myself Amanpreet Kaur from BSc Honors Maths Semester 3rd. So my question is, can you please suggest some reading books for Vedic mathematics to know more about its applications?
Yes, I can. Just give me a minute. I've got a book here. There's a friend of mine who has worked for even in Vedic maths for even longer than me. And he's written quite a large number of books. They're very good. And his name is Kenneth Williams. And this book is a very good book, Vedic Mathematics Teacher's Manual, advanced level. But if you have a look at his website, vedicmaths.org, there you can find his books, and these are very good.
Thank you, sir.
Thank you so much, sir, for enlightening the students and guiding them from your experience. I now invite Dr. Monica, Assistant Professor, PG Department of Mathematics, to extend vote of thanks to the wonderful and exceptional speaker of the day.
थैंक यू डॉक्टर नताशा। दिया ज्ञान का भंडार हमें, किया भविष्य के लिए तैयार हमें, है आभार आपका सर जो किया कृतज्ञ अपार हमें। A very good afternoon to all present here. I deem it a great honor and privilege to propose the vote of thanks on this occasion. Let me first of all start by giving glory to the Almighty God for making today's event a resounding success. First and foremost, I thank our special guest, Mr. James Glover, who, despite his busy schedule, has found time to grace this occasion. He has given knowledgeable and motivational talk on Vedic mathematics in such a simplified way. And I am sure all the students and faculty members have learned a lot from his expertise. I also express my heartfelt thanks to worthy Madam Principal, Professor Dr. Atima Sharma Dwivedi, for her valuable contribution and giving us the opportunity to do such a wonderful talk. With promise for similar motivational sessions in future, I am thankful to Mrs. Veena Deepak, Head PG Department of Mathematics, and entire organizing team who didn't left any stone unturned to make this event a great success. Thank you all for your active participation and for your patience. Now I would like to invite Madam Natasha for further proceedings. Thank you, sir.
Thank you, Dr. Monica. My heartfelt thanks to all the faculty members, fellow staff members, and technicians who were working behind the screen to ensure that this workshop is a success. Last but not the least, I owe special gratitude to our vibrant participants, not from within the college, from outside institutes also, for their enthusiastic participation. Once again, I thank you all for the kind attention. Thank you. Thank you so much, sir. And on the behalf of the organizing team, thank you so much for sparing your time and sharing your knowledge with the students. And we hope that in future also, if our students want to interact, we can always do the same through your email ID. I mean, we can share that with the students so that.
Yes, yes. That's absolutely fine. So thank you for inviting me as well. It's been a pleasure.